Hello everyone, welcome back to another GIS mathematics lecture video. And in this lecture video I want to begin talking about arithmetic. We've covered the key terms, scalar, vector, matrix, and how we measure dimensions, so hopefully you have those terms with a solid understanding. If not, I would go back and rewatch those videos until you do, because we're going to move on to some of the basic arithmetic. And in this video I want to talk about addition and subtraction. Now, the nice thing with addition and subtraction is that they work much the same way that we're used to seeing in traditional arithmetic. And what I mean by that, as we'll see in a second, is that we basically just add or subtract the different elements from each other. So let's go ahead and give ourselves a little bit of room here. And let's go through some examples. So I'm going to denote a matrix A, which I'm going to fill, and we're going to do this sort of conceptually with letters to show you where things come and go. And then in the next video, we'll go through some solid examples to sort of solidify this with numbers. So let's have two matrices. We'll have matrix A, which will have, I'll do these values in green or in red. So we'll do A, B, C, D. Okay? So that's matrix A. Then we will also have a matrix that we'll call B. And again, to sort of tie back into the idea of terminology, right, I'm denoting these matrices with capital letters. So this is a 2 by 2 matrix. Okay? Just to sort of recap some terms. And then B will also be a 2 by 2 matrix, and I'm going to fill these with the letters W, X, Y, and Z. Okay? And this is also a 2 by 2 matrix. Okay? So let's go ahead and ask ourselves, well, what does A plus B look like? Think for a second what you might expect it to be. If you thought that it would be A plus W, B plus X, C plus Y, and D plus Z, you'd be absolutely correct, right? That's how matrix addition works. So let's go ahead and write out what this looks like. Okay, so we're going to end up with a 2 by 2 matrix, right? Because we're maintaining our dimensions here. So the first element is going to be A plus W, right? The second element is going to be B plus X. Right, the third element is going to be C plus Y. And then the fourth element is going to be D plus Z. Ooh, keep my color coding consistent here. D plus Z. Okay? And again, we result in a 2 by 2 matrix. 2 rows, 2 columns. So I just realized maybe you're unfamiliar when I'm saying the term element. I don't think we actually defined that. An element is just a single value in a matrix. So A, in this case, is an element of the matrix. D is an element of the matrix. W is an element of matrix B, and so on and so forth. So an element is just an individual value in a matrix. So when we add matrices together, we add the individual elements. And we do not change dimensions. Right? Right? We do not change dimensions, right? We do not change dimensions. And this actually brings about an important rule, right? I'm going to give myself a little bit more room here, right? In order to add or subtract matrices, right? In order to add or subtract matrices, they must, and again, I'm going to underline this in multiple colors here, right? They must have the same dimensions. Right? They must have the same dimensions. And if we go back up here to our sort of conceptual example of addition here, right? How would we add something where B was a 2 by 1, right? Where B was a column vector, right? You couldn't do it, right? Because it would be A plus W, C plus Y. B wouldn't have anything to add. So the whole thing would fall apart. So again, we add the elements, we don't change the dimensions, and in order to add them to add or subtract, they have to have the same dimensions, okay? They have to have the same dimensions. So that's how addition works, right? We add the elements, A plus W, B plus X, etc., etc. Let's do the same thing, but with subtraction. Let's give ourselves a little bit of room. Let's redefine our matrices, right? We'll do A equals, let's do A, B, C, and D, just like before. And then we'll have a matrix called C. We'll matrix called C, and we'll set C equal to, let's do E, F, G, H. Right, there's nothing special about these letters that I've picked. These could be any letter we want them to be. I'm just representing abstractly how this works. And in the next video, we'll go through some concrete examples. Okay? So, how would A minus C look conceptually? Right, again, just like with addition, right, these are 2 by 2, right, 2 rows by 2 columns. We know our result has to be 2 by 2 because, again, we don't change dimensions and they have to have the same dimension. So we know our result is going to be 2 by 2. But what goes in each of the elements? Well, we know we're going to end up with our values from matrix A, so A, B, C, and D, right? Because we're subtracting, we're going to put subtraction here. And then we're going to bring in the values from matrix C. So right, E, F, G, and H. Right, so that's how subtraction works. Right? Very, very, very similar to addition. We're just swapping the sign. Instead of adding, we're subtracting. Okay? So hopefully that makes sense. Hopefully this idea of subtraction as subtracting the elements from each other, and hopefully addition, which is the idea that we're adding the elements together. Hopefully that makes sense. Hopefully, again, you understand that in order to do this, we have to have the same dimensions. Makes sense. And as always, please reach out. Thank you.